created the space that we can start hosting events like this and supporting community, something that Lean Techniques is founded on in the Des Moines area, and now since beyond the state of Iowa. If you're not familiar with us, you can check out our website, but really our focus is around building an organization of team members that really want to support advancing IT as a competitive advantage. Cool stuff and help organizations be successful. That's it. If you want any more information, let us know. Otherwise, enjoy. Please help yourself to beverages. Again, adult beverages in the fridge. Please eat as much as you guys can here. Our team servers. And I will now hand it over to my partner, Tim, to talk about an upcoming event in October.
Thank you, Danielle. My name is Tim Gifford. I'm CIO here at Lean Techniques, but I'm not here as CIO of Lean Techniques. Well, I kind of am, but I'm also here as the president of DevOps Days Des Moines. We have DevOps Days Des Moines is going to be happening on October 27th and 28th, I think, or 28th and 29th. It's one of those. It's Thursday, Friday at the end of the month of October. We do have call for speakers open right now until the end of July. So if there's a topic that you want to talk about, please go out to papercall.io. There, or you can go to devopsdays.org, and there is our Des Moines event there, so you can learn more. But hopefully you'll be able to join us on October 28th, 27th, 28th, 29th, something like that, Thursday, Friday. And then, there are adult beverages in the fridge. We are not a bar. So if you ask for a drink from me, I cannot serve you. I can say the beverages are in the refrigerator.
So you say the server is down?
The server is down, yeah. Awesome. Thank you. I'll turn it over to Brian.
Good. And this is Brian. He's Azure MVP and Microsoft MCT, right?
Yeah.
Go ahead and.
Yeah, cool. So let me share the screen here so that if it's recording, all that jazz. Is that good? I don't know. Teams and me, we're not best friends, so.
Nobody's best friend.
Yeah, all right. Okay, let's get this started with the formal thing. And this is where I love presentations because now it's going to say, oh, you want to do this? And then I got to do this. Sorry, 1 second. So that I can see what you see. All right, so this is an introduction to IoT with Azure. So first of all, how many people work with IoT at all? Okay, and that's it? Okay, cool. So how many people like soldering? Awesome, because we're not doing any of that either. Oh, you do? Okay, I'm sorry. Well, actually, I might have some questions for you later. All right, so this is me. Yes, as you mentioned, I'm an MCT, which means it behooves me to get a lot of Azure certifications, so I have quite a few. And if you have any interest in any Azure certs, please let me know. I'd be happy to point you in the right direction. Alex training him, so we're pretty excited for that. Yeah, so that's me. I'm an Azure MVP, just re-upped last weekend, which was really awesome. Give you the chance to keep doing things like this. What we're going to talk about today is actually a more high-level look at the IoT infrastructure within Azure and how we can start porting data into Azure. So if you like tinkering with your IoT devices and such, that's not what we're doing today. Although I did bring a nice device that we could look at some real data. What we're looking at is more going to line up with if you take the AZ220, which is an IoT developer specialty. So in order to do that, you have to know a few things about how the Azure ecosystem around IoT, and that's what I'm hoping to help you do today. So we'll start off, and we're going to take a whirlwind tour. So there's a lot of information. Everything that we're doing is going to be available as well in GitHub under my Gorman GitHub. I'll get you that at the end, and that gives you the chance to go through this on your own a little bit and see it in general. But we'll start with the basic ingestion at IoT Hub, which is going to be essentially, if you've ever worked with Event Hub, IoT Hub is a subset of the Event Hub. It lets us bring in data, millions of records per minute, and be able to take that telemetry from all over the world. We'll talk about how you can set up manual devices. The pointer doesn't show up on that TV. That's awesome. Or the battery just went down. No, pointer works, not on the TV. Cool. All right, so that's not going to work. No, I guess I need to flip slides, don't I? But yeah, so IoT device provisioning service then brings us to the chance where we can start doing automated enrollment. So obviously, if you have a fleet of devices, you don't want to be manually enrolling each one. So the device provisioning service, or DPS, will allow us to bring a bunch in, and we'll look at certificate attestation for that with some previously generated certificates that lets us just automatically authenticate and enroll into the IoT Hub. We'll talk about the Lambda architecture, which is the hot path and cool path for bringing data in and how we respond to that in time or over time. And then ultimately cold path storage being our landing zone for our ingestion for all the data. And then if we have stream analytics to the hot path, what that does is that allows us to create a filter on the data. So if we have telemetry that's out of skew, we can send that to our hot path, which we then use something like Power BI or Grafana to put all that data up so that the people who need to make a decision right away can do that. And then I'll talk briefly about the IoT Edge, IoT Central just a little bit, but not too much at all. So the IoT Hub. And a lot of what I'm doing here, again, these slides are going to be out there for you. So any links and stuff, don't worry about it. You can get them off on GitHub in a minute. But ultimately, this is going to line up a lot with some of the free material that goes along with the AZ220 exam. So you have the IoT Hub here is ultimately got a bunch of labs around it. And this is part of it. This is one of the labs. I've combined a lot of it to make it much more succinct for this presentation. But the idea is there's things, and then there's your ingestion or your insights, and then ultimately your people making your analytics decisions. So ultimately our devices are going to be out in the cloud, out in the world, wherever, driving around on trucks, whatever it might be, riding on boats, different things like that. We have to get that data back into Azure so that we can work with it. And that's what the IoT Hub is. So again, it's a subset of the Event Hub, so it does have partitions just like an Event Hub. It has the same sort of ingestion mechanism. In fact, the SDK code for the IoT Hub and the Event Hub work in tandem, so you can use the same code on both. And the code is very easy to work with, and you just need a connection string, and you can connect and start sending data right away. And so ultimately, I have all this stuff pre-provisioned so that we don't have to spend all night here watching stuff work at Azure. And hopefully we can find it real easy and get it working. Excuse me. So this is my IoT Hub. And at the IoT Hub, when you provision it, you ultimately set up the number of partitions you want and a number of things around the throughput and such based on the pricing and tier you want. So there's a free tier, there's a basic tier, and there's a standard tier. And this is the standard tier that I'm in here. And the free tier is exactly the same as the basic, or excuse me, exactly the same as the standard tier. It just has limited number of messages. So 4,000 messages per day versus like 400,000 or something. The basic tier is going to do all of the stuff that these do, except for both the free and the standard tier can send cloud to device messages, whereas the basic tier can only send device to cloud. So you can't go back and forth in the basic tier. That's the main differences. Ultimately, once you get it provisioned, you'll see over here on the left-hand side, you have devices and let's see, so that's right over here. You have devices and the IoT Edge there. These are where you can put your devices in. And so we'll get out of that. And then ultimately in my devices here, I've already pre-provisioned the Simulatron 2000. I have a vibration sensor 2500, which I just tested a minute ago to get the attestation to make sure that was going to work. So let me just delete that one. Then I have my RetroPie, which is over here. We're going to try to connect to that at the end and see if we can't get some real data. We're going to concentrate on sending data via the stream today from the IoT Hub, or from the IoT simulator to the hub, excuse me. That's basically the first part of the hub there. Did I lose my slides? Right, so once we get our devices, we can manually enroll them, and that's what we're going to do. So when we manually enroll them, we'll have a connection string that we just basically can use based on the keys that it generates. So we go out, we say we want to create a device. It gives us a key. We can use that. This does really nice for testing. It's not real nice for like repetitive doing this over and over again, which is why the DPS is going to come into play in a minute. So ultimately, we'll just do that with the C# simulator. We'll send some code. I also wanted to point out there's a free tool called the Azure IoT Explorer. They have a lot of these tools. They're a lot like Visual Basic or Visual Studio Code, the Explorer, Storage Explorer, IoT Explorer. This is just a free download that you can get. It's a super awesome tool to work with locally on your desktop and be able to read your data directly from your hub without having to be in the portal, the web. So it works just like you're connected to the portal, which is super awesome. You can see your devices, you can get your connection strings, you can see the telemetry coming in real time through the IoT Explorer. Yeah.
Does it use 443 or some other port for access with SSL?
Oh, I'm not sure the port number.
Just curious.
Yeah. So are you talking about for the IoT Explorer? Or are you talking about the devices themselves?
IoT Explorer.
Yeah.
It should be standard SSL.
Yeah. Okay.
I just wanted to ask.
Thanks. Yeah. Yeah. I guess I've never really cared about that too much. So cool.
Cybersecurity thing.
Yeah. Nice. So the other thing is within the device, this is also a cool thing. You can actually send what you would like to have the device do. And ultimately, if you code around this, you could make your telemetry being reported back at a less or a faster interval, depending on what you need. So as you get more devices out there, you may only want telemetry every 5 minutes instead of every 1 minute. So this is what they call device twin. And the device twin is a digital representation of your IoT device in the hub as it exists out in the cloud. And so then ultimately it has a desired property and a reported property, which are highlighted here and a little bit hard to see. Let me see if I can get a little bit close. Of course I didn't. Trying to watch the TV and talk on this thing at the same time. But there you see the desired property and the reported property. Ultimately, I send it, I say I'd like it to be 4, and then it'll send that out. And then once the cloud device has responded, I'll get my reported property back to say that it's 4. That lets me communicate between them. And you can do this from the Azure IoT Explorer as well. So you don't have to go into the portal to do it, but you can also do it through the portal. And so that's what it looks like in the hub on the twin in the Azure portal versus in the IoT Explorer. All right, so cool. We're ready to add a device. Let's go ahead and take a look at what that looks like. So ordinarily, you come into your hub and you hit this add device section here. And that gives you the chance to just add a device. When you do that, you can choose if you want to use a symmetric key or a self-signed, or if you want to use a certificate authority signed, X509 certificates. So symmetric key auto-generated allows me to very easily create one, and I just give it a name. So let's just call this temp test device or something. I add this in, it'll give me the key that I need, and it's right here. I can drive into that device, and there's the connection strings. So the connection strings basically allow me to connect that device to the hub through code. So I already have that set up on the Simulatron 2000. It has its own connection string, and ultimately in my code, I have Simulatron 2000 set up to send device telemetry. So actually I want to start the IoT Explorer here as well, so we can see. Just a second here. This is what happens when you present from home a lot and you don't have to worry about not having a second monitor. So now it's like, okay, so here's my environment hub. And so there's the temp test device I just created. Unfortunately, this is really small. And every time I hit the wrong one, instead of control, I'm hitting. There's the devices that we have. And this is the Simulatron device that we're going to be looking at here. If I drill into that, you can see the connection string, but I can also watch the telemetry here. So this says telemetry. I know that's really small for you guys right now. And ultimately, I'm just going to start that to start receiving events. So it's basically just like I'm on the hub at this point, watching events come in. And as I run my code here, I'm going to select the option to send my telemetry via connection string, which is going to be that Simulatron 2000. So it's just sending some data. So this is just a simulator that Microsoft built, and it sends vibration data. One of the labs talks about vibrations in a factory where basically your vibrations start getting out of whack, you'll see the color should change here to red at some point, kind of saying, hey, we got some bad data coming in. We should probably do something before the factory blows up or whatever. The cheese doesn't get produced fast enough or whatever it is. At some point, it usually sends some bad data, but what we should be able to see is that we should be getting data, and apparently this isn't keeping up, but we should have been getting some telemetry here as well. And then ultimately, that's telling us that the telemetry is coming in. And from there, we're ingesting it into our hub. We typically capture it at that point and throw it into the cold storage. That's how we keep that. All of that data is being leveraged. So the code to do this is actually quite straightforward. Ultimately, you just need to use the Azure IoT SDK, and you need a connection string and just a couple of other things to do this. So once you have the device client set up, you just get your connection string here. And then ultimately, you just ask the device client to create from connection string and using the MQTT transport protocol. So single device is going to use MQTT. The IoT Hub, I'm not sure if it can do, the Event Hub, I'm not sure if it can do MQTT. I'm assuming it can, but typically in the Event Hub, you're using AMQP. And here we're using MQTT for the single device. So just a typical transport type, but you can use the other ones here if you want to switch it out. See that they have AMQP, HTTP. So here's the thing about device transports. So AMQP is going to be your typical one that you're going to use in the Event Hub for lots of big data coming in. MQTT is going to be a single device going in. You're going to want to use one of those. Those are WebSocket based to connect to your hub so that you don't have to reestablish the connection. You can do things over HTTPS, but there's an overhead of reestablishing your connection on every connection. So you don't want to do that if you're sending millions of records, because it just wouldn't make sense. You'd be creating your connection over and over again. Sending the device message to the cloud then, this is just generating it out and ultimately creating it and then create the message. Yeah, so ultimately, similar to what you would see with a service bus or any other messaging protocol, we're going to serialize our stuff and send it in as binary. We're also mapping it here. This is saying we want properties for sensor ID and BS log for a log. We want properties for belt alert. So we're adding these properties to our message to decorate it a little more so we can do filtering later. The stream analytics job is going to look for things like BS log or BS telemetry on one of them. Let me find that real quick. And so the telemetry message is sending off the telemetry for the sensor and ultimately tagging it with this property for VS telemetry. So now I can create a stream analytics job, focus on that specific key, and they'll get get only the telemetry coming in that maps to that property. Then I can filter it further to determine, is it within my output that I'm looking for. Cool. Everybody okay? Any questions so far? Yeah.
So have you, in the real world, what kind of digital twinning thing have you seen most successful?
So there's actually, so the digital twins that I showed earlier here was a very basic one. It basically just lets me send data back and forth to that expected thing. There's actually an entire platform service called the Azure Digital Twins. Okay. And that allows me to create an electronic overlay of all of my devices. And that's what you're going to want to use in the real world, because it's going to have the ability to map all your connections and other stuff. I have a video on that I can point you to after.
I sent you a LinkedIn invite, so.
Okay, cool. I'll do that. That one talks about trucks and watches the trucks go around and stuff. It's pretty cool. So, all right. So we did device and simulated telemetry. So let's do the device provisioning service. So as I stated, when we're looking at doing this for the real world, we need to have the ability to do millions of devices or hundreds of devices at least, and doing them one-off isn't good. So the DPS is an additional service you add in to allow automatic authentication into your hub. And so what you do is you basically create an enrollment group, and the enrollment group lets me say, while this is active, anybody who can authenticate against this enrollment group can join my DPS. You have a root certificate. It's typically done through certificate authentication. So you have a root certificate and leaf certificates. So your device will need to have a leaf certificate on it, and that allows it to automatically enroll. And then ultimately, once you're done enrolling, they can communicate just like they're connected. Later, we're going to talk a little bit about the Edge, and some stuff gets a little wonky there. It still has to enroll back to the main, but once it's enrolled, it'll only need to report to the Edge. So that's a little bit different. But other than that, it's pretty much the same process. So yeah. APress is, again, just another service at Azure, and it lets us be able to quickly and easily register our devices. So device provisioning services. And ultimately, I have the Enviro monitor out here for that as well. So main things about this is you're going to need a link to IoT Hub. Oops, this is what happens when you flip off your presentation. Sorry. All right, cool. So I have a link to IoT Hub, which is, of course, the hub that I've created. And then I have shared access policies, which allows me to be able to join into this device provisioning service and do things against it, different permissions and such. Then I have my certificates. So I've run this a couple times, and so I have 2 certificates here. I really only needed 1, but ultimately the root certificate allows me to have all my other devices can use that certificate as its joining chain. And so we add that in here. Typically you call it root or whatever you want to call it. And then you have to verify your ownership. This used to be a lot more involved than it is now. Now it lets you verify your ownership during the upload of the certificate. Whereas before you had to upload the certificate and then generate a new one, to verify your ownership. That was really a 2-step process, but they've improved that greatly. So the root certificate just basically lives out there, has all of its information, and that lets me be able to join if I have a leaf certificate that maps. So within my enrollments, then I have different enrollment groups, and then I can have individual enrollments as well. But the enrollment groups let me join devices automatically. And so in there, I can do different things about this, how I want to set this up. Is it an Edge device or not? I'm using all regular devices today, no Edge devices. But if it was an Edge device, you could turn that on. If you want to do a certificate assigned or an intermediate certificate join, you can do that. Which you select a certificate for your primary. If you have a secondary, you can choose that here. You can do some different distribution across hubs. Evenly weighted is basically like round robin, so that's typically what's the default. But there's other is available as well. And then ultimately, the hub that you can assign to. So if you have multiple hubs, you can run this across multiple hubs. Ultimately, then you can also set the initial device twin state for a device that joins here. So again, we have that desired telemetry delay of 1, which just lets me send back data every 1 second or whatever. I could change that to 4 and make it every 4 seconds, however it might be. So that's essentially the enrollment policy. Now, here's what's really interesting about this. I have these enrollment groups, and right now it's enabled, right? So anybody who has a certificate can join onto my IoT Hub through this route. If I disable this, I can no longer join. And what you might think is that means my devices would stop working. That's not true. If my device is already on the hub, it will still continue to report. So if I need to remove a device from my hub, I need to do 2 things. I need to disable, and I need to go and actually physically delete it off the hub. So that way it won't keep sending me data. And if I forget to do both, I'll either get data from the fact that it was already joined, or I'll take it off and it'll just re-enroll itself the next time it sends data. So that's just a 2-step thing that you got to remember to do if you're using this. Probably won't be a big deal, but it's nice to know. Okay, so that's pretty much the device provisioning service. So now we're going to use it to do some device attestation. So what I did was I pre-joined those certificates, and I created 3 device certificates here in my code, which is again really hard to see, but ultimately one for device 2500, 2600, and 2700, and then ultimately I just wrote code to join on certificate attestation. So use the device certificate client. The code then ultimately, again, a lot of this is right out of the training material as well as available on my IoT intro GitHub, so you don't have to worry about it. It's like, I want to see this later, it'll definitely be available to you. But we're just going to grab the certificates. We're going to use the password and such that it basically used as default. We're going to add those devices in. It's going to try to use the right file, and then it's going to grab the device provisioning device client. It's going to use that. Oh yeah, one other really critical point is this global device endpoint, which is always the same for all Azure IoT, and that is going to be, usually you put it in a global variable up at the top. It's going to be this global.azuredevices provisioning.net. So that's typically, got to make sure you have that correct, otherwise you would not be able to connect your devices. You also need the DPS ID scope in order to connect. So that's actually found on the DPS itself, which is this little, it looks like 10065.9E74 for mine. It's O&E or 0NE or whatever that is. You can just get that and use that scope along with that global device endpoint and then your certificate, and you'll be able to connect your devices to your hub. All right. So anything, I think pretty much, so it gets the twin, basically just configures it, sets it up, adds it to the hub. So that's loading the certificate and ultimately provisioning the device here, which is going to do a new device authentication with X509 certificate, getting that certificate, get it set up, and device client create. So let's run this, and what we can see is now in my code here, option 2 is for certificates, and then I'll do device 2500. It's going to say I found device 2500, and then what I can do is debug and start a new instance here. Sorry, this is really small for you guys again. Let's go. We'll start that one up as well. Okay. Have multiple devices registering themselves and sending telemetry. And then if we want to, we can actually send a twin change to one of these so they report at different levels. So for some reason, we decided we want to change how often one of them is actually reporting back to us. We can go back to the hub, or we can do it through that IoT Explorer on our local machine. Find the device you're looking for. So here we have the two devices, the sensor 2500 and 2600 that were added. So let's tell 2600 that we want to change its telemetry from 1 second to, let's go to 5 seconds there. So I'm changing that 1 to a 5 for that telemetry delay. And I'm going to go ahead and save that. Now that'll send that out to the device, and the device will then adjust its properties, and we should see a skew then on the two devices sending telemetry. Do one coming in every 5 seconds and one coming in every second here correctly. Ish. It's like it broke it. I don't know. Not reporting back or something. There it goes. Okay, so I was just not being patient. There would have been also a notification here. At one point, it would have sent a notification into the readout that it changed its telemetry. And then, of course, the other thing is you can come back here, refresh this, and we should see our desired and our reported should now map. It also maps when you last updated it, so you have all that information available. So, yeah, that's super basic way to send a device to cloud message, but that didn't really do anything. And also, I had to code for that, so I had to check the telemetry delay and then use that as a setting in my code. So there wasn't anything special about my device that's like, oh, the telemetry delay is already configurable. It's because basically told it to use whatever I send there and give me my telemetry delay. So we responded to that with the undesired property changed event, and then ultimately set that to that 5 seconds instead of that 1 second. So, but that's a quick and easy way to get going and start working with it. So now let's take a break from the IoT stuff that we have in the cloud, and let's talk about architecture a little bit. So Lambda architecture. So this can confuse a couple people along the way when it comes to talking about cold path versus hot path, especially when we start talking about storage. So if you're familiar with Azure Storage, there's archive, cold, and hot tiers. And those are used for different access and storage cost management within your storage tiers. So if I want to access things very often, I put it in a hot tier. If I want to access things infrequently, cool tier. It just needs to be around for legal purposes, archive. When I'm talking about a Lambda architecture, I'm talking about responding to data as it happens or over time. And so ultimately, this is a really big deal when you're in the real world because you're going to have reasons that you want to respond immediately, whether a building's too hot, maybe there's too much particulate matter in a hospital operating room, you need to get somebody on that right away. There's all kinds of different things you could put, and what you do is you create a stream analytics job on top of the stream we just put in. You then filter that data based on the telemetry that's coming back, on the properties and different values in there, and say, okay, if it is outside of my SKU, I want to send to the hot path. And the hot path then is where my analytics people are watching to make sure that stuff is being handled. There's a warm path as well, which is kind of like, okay, this is the last few days or whatever, the last few hours, whatever your warm path is. But then the cool path. The cool path is everything. So my hot path is, this is critical, I need to respond to it. My cool path is, let's keep everything so that we can do a postmortem later. We can figure out what led up to this event over the last 7 days. We can do sliding time windows over that. And so the cool path is going to be stored in Azure Storage typically. You put all of your telemetry into there, and the difference between typical Azure Storage and what you're doing with this is you're going to turn on data lake. So you get the full hierarchical ACLs or ACLs, however you want to say that, and the actual folder structure that comes along with data lake that you can do further analytics. You can do sliding time windows with time series events, different things like that to see what's happened leading up to that, so you know next time. Or, you know, if something breaks, you can start recognizing patterns. Hey, our trucks keep breaking down after 7,000 miles. What's going on? You know, like what was leading up to that? So that's kind of what you're trying to set up here. So ordinarily what you do is you set up your stream analytics job behind your IoT Hub. And so it basically has to connect. You get an input, which is going to be your IoT Hub data, your output, which is going to be your cold path storage, and then there's a query. And the query is similar to a SQL query. You're going to write something like some range query that basically looks at that. So this is using message routing to do that. So within that, so you can create a message route to do that, that routes the data from IoT Hub into storage. And the stream analytics for the hot path is going to be more useful because that's where we're going to be able to do that quick query filter to see, are we out of SKU, and send it off to Power BI or Grafana or whatever your other reporting tool. So you ordinarily create inside of your stream analytics job, you create again your input, which is going to be your IoT Hub, your query, which is the selecting star into telemetry output from the input, where the vibration is greater than 1.5 or less than minus 1.5. So I just created some silly numbers here just to kind of show that it could work. So I do have that set up a little bit. I think ultimately it gives us a chance to see it a little bit. This is kind of the one area that's less tested, but it's very easy to get them set up. It's just hard to get it to read it correctly because there's a lot of hoops to jump through, and it just seems like starting the stream analytics job takes a few minutes, and it's hard to get it right on the first try. So you create a stream analytics job that's basically going to, again, have that input based on the hub that I'm looking for, the output, which in this case is going to be blob storage, which is the data lake storage, and then the query, which is again that selecting from the telemetry. So it's saying right now that there's no test results, which is bad news for me, because that typically it would show data here if it's actually able to see stuff. I can try to test it here. Yeah, it's telling me there's no data. So sometimes I struggle with this part, getting this to work up. So let's just start the job, see if it's actually going to run anything. But what you'll see is that starting the job and stopping the job takes a couple minutes to actually get that stream analytics job working. Oops. And so, yeah, so something's wrong with my input. Probably I deleted something or something along the way by accident. So I don't really want to make you sit here and watch me try to troubleshoot what's going on here, but it looks pretty good, honestly. The important things are, how do I want to save this data? So I can save it as CSV, JSON, or Avro. It used to be all just Avro, which is really cool. Now you've got some other options. JSON obviously being probably preferred for most of us, but Avro, if you're using something Apache Landscape, would be your choice. Yeah, so there we go. Okay. So yeah, so ordinarily that stream analytics job would then filter that telemetry that's coming in. You would see, the records that are out of skew and say where it's going. I got to figure out why that's not working. I'm sorry about that. But, yeah. So any questions so far on any of this stuff? Throwing a lot. Should see. So yeah, so that anomaly detection would be where I would want to use that stream. Look at my trends over time, or whatever that input query I did there, be like the temperature's going out of range, too much light in the room. There's also a couple of like Azure examples on. They used to have a nice one on like figuring out how to like watch for when your devices are going to. I could look for that afterwards. Other questions? Yeah. 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 So every Azure service that's monitored, you can set up an alert on. So yeah. So we got that. Yep. Oh, okay.
You know,
That's a really great question. I don't know the answer to that. The stuff I've done has all been manual, but I'm guessing that you could use cognitive services and port your data there from your big data pipeline and send it off and get cognitive services involved for sure. Machine learning stuff, yeah. Yeah, because you can have different outputs. It doesn't have to be blob storage. So I'm not sure if cognitive services is direct output, but. So Azure Data Explorer, Azure Functions, Postgre, Synapse, SQL database, table storage. So those are my different outputs I can put all my data to on my stream analytics job. So if I wanted to port it into a SQL database, or your Synapse Analytics, I can put it into my Synapse, which used to be SQL Data Warehouse. You use that to further your machine learning from there.
so you can also use cognitive services to bring your blob storage container.
Okay.
Contents in there, and train a model based on that stuff.
Perfect. That'd be awesome. Because then you already have the data. You don't have to pay for Synapse Analytics. Cool. Yeah.
So within Synapse Analytics, what kind of tools are inside of there for you to throw all that like data into?
That's a great question. So Synapse Analytics. So have you ever used SSIS? Okay. SQL Server Integration Services. So the whole purpose of Synapse Analytics is going to be around big data.
Yeah,
Basically
no.
Yeah, ETL. So with
ETL.
Yeah, okay. So within Synapse Analytics, there's basically Azure Data Factory, which is a standalone ingestion tool, but you can put inside of Synapse Analytics, they basically have a second version of Azure Data Factory. It's Synapse Analytics Dashboard or something like that. I don't remember what it's called. It does the same thing. You basically can do your extract, transform, and load on all of your data from your Azure storage or wherever your source is, and you can put that into you know, your data cubes or whatever you want to do with it from there.
Yeah. And what kind of, anomaly detection models are in that system? We'll talk about machine learning.
So the machine learning stuff that I'm aware of is all within the Azure Cognitive Services area.
On that side of it.
Yeah. So I don't know about anything in the Synapse Analytics.
Okay, well, I just maybe that in the wrong box.
Okay.
So is that, what kind of machine learning tools are the cognitive? Is there a list or something?
Yeah, so there's all kinds of, basically every machine learning thing you can do in the world. There's voice, there's text, there's speech, there's document recognition, there's train your data science model and build stuff, whatever you're trying to do. You can do all that in cognitive services.
Okay, so it's all under that.
Yeah. So, and I don't know if Synapse Analytics directly relates to that. If anybody knows, please speak up. But
Yeah, I mean, analytics is something from the cognitive services.
yeah,
Oh, it is.
It's all under the Azure umbrella, from a category standpoint. And analytics will be in cognitive services.
cool.
Is there somewhere? That's a joke, yes, I don't like that.
Yeah, go to Google.
Okay, sorry. I was like, there's a Google engineer who just got fired for that, right? Okay, so the edge. So I'm not going to show anything on the edge, but I'm going to talk about what the idea of the edge is. For me, the edge was a scary thing at first. I was like, what the fuck about the edge? What does this even mean? It's a whole other ecosystem within IoT, but ultimately all it is I don't want to bring millions of records into Azure. I have 50,000 devices in the world, and I have them in, let's say, 20 buildings, right? I have 20 buildings that are basically edge points then. So it's distributed computing is all it is. We're going to move some of the stuff out into the world so that we can get better stuff happening. Quicker responses on-prem and only not overload our Azure. So what happens is you create an edge device, which is just another device in the edge, or basically out there, and then you can have an edge gateway, or basically a gateway at that building that they can connect through, and you can do stream analytics, you can push it out into that edge gateway, and ultimately any device that can install the IoT Edge runtime, so a Raspberry Pi can do it, you can do it on VMs if you want to test it, any machine basically can host the IoT Edge runtime. That can be an endpoint to kind of throttle your ingestion. So now 50,000 devices across 20 buildings, I'm only going to send half of my data back to Azure, so I don't overload my Azure IoT Hub. And I'll handle stuff on the edge, do the processing out there. And the stream analytics job. Where it gets really tricky is you got to use containers. So if you're not a Linux person, which a lot of .NET developers aren't, it's a learning curve. But you basically package your edge manifest and you put it into a container and push it out to the edge. And you can do all through the hub and all that jazz. It's not super hard, but it's just a little bit of learning curve. There's also a bunch of pre-built ones. Obviously, stream analytics jobs is a big one. SQL Server on the edge, so you can put a SQL Server out there. Different things like that as well. So that kind of looks like this. Ultimately, you have your IoT Hub, you have your edge device, which could also be connected to a gateway hub out there. But ultimately, the edge device is running the edge runtime, and then it's basically able to handle jobs like it's the IoT hub ahead of time a little bit. So then we push stream processing out there. We can only, now instead of sending all of our data back to the Azure ecosystem, we write that same kind of query. We only send the interesting data back to the Azure ecosystem. Everything else is just thrown away or stored locally on files or whatever we want to with it. So again, it's just an idea of distributing computing, getting it out to the world so we don't have to bring everything back. It's also highly useful in scenarios where you don't have good connectivity. So if I can't connect to the IoT Hub, that's a big problem. If I can still process, that's a great thing. The main thing I mentioned earlier is in order for a device to register to the IoT Hub, it still has to connect to the IoT Hub, even if it's using an edge gateway. So once it's connected, it's good. It's just that initial transport connection needs to be established. There's another tool, IoT Central. So if you don't like coding, you like low code, and you want to play around, IoT Central has a lot of really cool projects. These are called what they call plug and play. So if you don't like to code a lot, or you just want to see what can I do with IoT, IoT Central is its own little ecosystem. And you build these applications, and you can register devices, just like if you had a hub, do all the cool things we were doing in the high code environment we were just looking at, but more probably targeted towards your business users and less towards your developers, right? Okay, so that's all I have for IoT Hub stuff. So now it's the fun stuff. I decided that I wanted to see what this would look like to actually do a real device. So I bought an Enviro, Pepperoni Enviro, and that was like $30. And I bought this little connector thing, which if anybody used to work with computers when they were back in the days when we had the hard drives and the IDE cables, it looks a lot like that. And I had, for reasons, and a Raspberry Pi already, so that's why I went this way. So you see I have this device over here, and this is the Enviro sensor and the connector. It's connected to the hub, or to the Pi, and I did 0 soldering. So for about $50 plus or minus, and then, you know, whatever your Pi costs, you could get started with this. But the interesting thing is that I bought the wrong Enviro. So there's a second version, which was $20 more, that I actually wanted, because it comes with a connector for the particulate matter sensor. And I have that, but I don't have the wiring and soldering capabilities to hook all that up at once. I also bought a camera, and I put that onto this and wrote code for that as well, which is cool. But the code is such a hack. It's kind of fun. At the end of the day, the code to connect from the Raspberry device is exactly the same as the simulator. It's just using the same connection string, doing the same stuff. It just has to run on that device. So you gotta get .NET running on your Raspberry Pi, which is not hard to do now that it's open source, and we can do Linux boxes and such with it. So that's cool. And the other thing, I'm forgetting something. There was one other little trick. Yeah, I'll remember it eventually. But here comes the fun part. So I know I'm connected to Teams, but because that doesn't have a screen or nothing, in order for me to connect to it, I need to be on my phone network, and that will connect through my phone. I set this up ahead of time so I don't have to be connected and do all this stuff. That will connect and let me connect to my hub from here. If you guys don't know this, Visual Studio Code has phenomenal SSH tools. I didn't realize this. You can actually write code over SSH from Visual Studio. It's the coolest thing.
ZSH units.
Okay. I don't know what that means, but okay.
That's a shell that's been around for since the 90s at least.
Okay.
That lets you do remote command sense.
Oh, nice.
So it's great stuff.
Cool. So yeah, so I think it's fun messing around with this stuff. So you can literally connect your Visual Studio Code right to. I gotta switch networks here, but so I'm sorry, this is probably gonna drop me out of the Teams meeting. Is that a big deal? And I can use my Raspberry Pi via SSH. I can code it from here, which is awesome. Once I get connected. Cool. There's always an update for Visual Studio Code, by the way. It's crazy. All right. What's that? I put ahead of time, of course, the entire project. This is the exact same repo from what you guys were just looking at. In code. So I'm just going to do a .NET run. And I'm going to be able to connect the Pi, sending data to my hub. So if I look at the IoT Explorer and we go back to the devices, the Pi, and start the telemetry here, you should be able to see that once that starts. Teams is not happy with me, as usual.
Still MQTT, screen.
Yeah. Yep, everything is exactly the same. It's just I just changed it from using the simulator to the actual device, put the code on it, yeah. So I'm gonna show the telemetry here. So hopefully this will start showing telemetry. So there it is. And then we should see it eventually coming in here. I'm very impatient when it comes to this because I'm like, come on, just show me. But you can see that it's 21.1 degrees Celsius in here with 44.18% humidity, and we're at 264 meters above sea level. We have 83.32 lux of light, whatever that means. Yep, 982.8 hectopascals. So I probably can't do this fast enough, but it seems to have locked up, actually. It's awesome, which means either I lost my internet, Teams take over and take over my internet. Yeah, so that's awesome. Teams, I'm sorry, Derek. All right, and then ultimately, I got to share, don't I? Come on. Okay. All right, and ultimately, yeah, this is like the self-appreciating hour, right? Yeah, right. So at the end of the day, that was SSHing from Visual Studio Code. So yeah, so we did that. In live temp summary, these things we covered. Basically, super easy to get started. Use a free tier hub, play around. And for $50 plus a Raspberry Pi, you can actually do some really cool, fun things. DPS for automatic enrollment, different transport protocols, but MQTT for device usually. So this is me. Brian at Major Guidance Solutions, Twitter at BL Gorman, LinkedIn, Brian L. Gorman. And then if you would like to support me, whatever reason, you can listen to my music on Spotify. Have a pretty good one. It's all Christian though, so just be aware. And then also, I have a free AZ900 course that I did in April. There's 8 hours of live training that's all recorded. Watch that if you're interested in 900. That's out at training.majorguidancesolutions.com. So there's also a book, Practical Entity Framework, if you like that sort of thing. So, cool, that's me.
Thanks, Brian.
Yeah.
And thanks, LT, for hosting our event. If you guys want to talk at any of our user groups or DevOps days, let us know about our user DevOps days.